Okay, so there's a never-ending stream of cool stuff in C++. Now let's have a look at templates. Actually, let's start by commenting this out. I mean, when someone from the outside, so to speak, someone from C Sharp or Java comes to C++, they typically look at templates and think that's the same thing as generics. I mean, generics in C Sharp and Java. So, I mean, in C Sharp you have a list of T, and you have, it's an array list, I think, in Java. So, I mean, yeah, that's not false at all. The thing is that templates is more than that as well. I mean, so far when we have created our vectors, you can see this is pretty much the same. I mean, we have used generics. We have used this is a templated class. We will actually create a templated class in just a few minutes. But let's start by looking at templating and how it's more than just generics. So let's say then this is our task. We are supposed to write I call it my max, because there are max functions in the standard library and everywhere. So it's but we want to write a function that will return the, let's say, let's say biggest, like that. Okay, actually that was not a good name. Fine biggest. Okay, anyway. So what we could do is, of course, what we will do is we will create this function then. And it will return an int, right? It will find the biggest from I, J, and K. We could do something like if I is greater than J and I is greater than K, then we return I. Just give me a minute. If instead J is the largest, like this, we return J, otherwise we return K. Okay, never mind if it's, actually it doesn't matter if it's, if all three are the same or anything, it will still return the biggest, yeah. Alright, so this will certainly work. I'm pretty sure it will. What we can say, it might be exaggerating a bit, but this is, we could say this is an algorithm. It's not the hardest algorithm to come up with, but when we have come up with it, it's kind of, we wouldn't want to you have to rewrite it or so. Okay, just give me a minute and I will run it, and I will continue talking about that. Oh, sorry. Okay, so I have some old code here. Okay. Okay. One more time. All right. So the biggest is 21. Fantastic. Let's say that the boss wants you to, oh, you know, that fantastic algorithm, it's a really good algorithm, but we should be able to use it with, say, floats as well. As well in our program, so you shouldn't replace int, we should be able to use it with floats as well. And we could maybe, okay. And as you can see, this already seems to be working. And let's do this as well. And it will work. At least in this scenario, because there is explicit typecasting. Anyway, so yeah, it seems to work. Great. Let's say this as well. Now the boss comes back again, and he says, okay, so that algorithm, I mean, it's fantastic. We need to use it when sorting our customer names as well. So we need to get to which should be the first one when we are sorting our customer names. So now we're talking strings. Oh God. So we're talking strings. And now I'm just saying, so the first name is Stefan, and just give me one more. Let's call them S1, S2, and S3. And let's call them, and like this. Okay. And now we should be able to get the biggest, so to speak, in sorting order, that is. Because I mean that's possible with strings as well. String big. And now you can see it doesn't work anymore because there is no implicit type conversion and so on. So what we could do is we could start copy and pasting this fantastic algorithm. So I mean, we would probably we would like to have the double. Just that's no problem. Let's just replace it, you know, like this. We're done. Because this will then be an overload. It will soon update. There it is. And as well as the string. So we could use, as you will see, the algorithm is the same. We are reusing the algorithm, but it's, I mean, we are duplicating our code 3 times, and that's a bad thing, because now the boss says, okay, so you need to add some logging, and we should add some logging when it's called, and we need to add it in 3 places. So this is a bad thing. So what we do instead, we use the cool thing called templates. So let's say, as you can see, think of templates as I mean, it's kind of like macros, but they are much more type safe, and you can do a lot more things. So, but so there is a keyword called template, and in here we could say type name is T. Okay, so what this is, I mean, this is a modifier for the thing coming after, and the thing that's coming after is a function. We will do the same thing. We will templatize. Can you say that? We will make a templated class in just a minute or two. But anyway, now we can use this T, and we can use this T wherever we want. Like this. And the cool thing is now that when we start using it, I mean, this code won't even exist until we start using the code. So this is not a, this is not a function. It is a template that might be a function at compile time. So far it's nothing. And still, it's nothing. When we compile, there won't be something called find biggest or anything. But when we start using it, and we start using it here, what will happen now at compile time, the compiler will look, as you can see, int find biggest int. Okay, this looks like, you know, this stud vector movie. So this is a generic version. It's a specialized version using ints. And what will happen is that it will, when we start using something, and we could do like this, of course, if that looks, more familiar to you. So here we, as you can see, we in C++, we not only templatize classes like, vectors or lists or whatever, we can also templatize, make functions templated. And that's what we often do. These are pretty, I don't know, not dumb examples, but it's maybe not the most useful. Actually, it could be. I typically use templates for, logging functions, or typically you see templates in, frameworks like graphical UI frameworks. It's often templatized because it's kind of the same, but it's not the same. It could be a different type of windows, like a list box or a button, or anyway. So it's not, it might not be every day we use templates. Anyway, so what will happen now is that the compiler, when it finds a usage of a template function, it will generate the code for us. So there will now be a function. So it will replace the t with int, because that's what we're using. And we don't need to specify that int, because as you know, a lot of things can be inferred by the compiler. So the compiler sees, okay, they are using int, and therefore the t is int, so we don't have to specify it. But this is still it is still templated. So whenever we hover, we can see it's a specialized version of the generic function. All right, and that's cool. And we can do the same here. And as you can see now, the compiler has generated a function for us, which will use floats instead. So this way we generate functions on the fly, actually at compile time, but we decide if we even want to use it or not. So a lot of things in C++, especially in the standard library and so on, is using templates. It's called standard template library, and it's so powerful. Let's have a look at this one as well. Okay, yeah, that's my fault. S1, S2, S3. I got kind of nervous there. Okay, so as you can see, in this we have one single function, or a template for a function. So it's an algorithm, and it's modified with, in this case, the type name. If you Google, you might see the class as well, template class. I typically use type name because type name, I mean, they are interchangeable. But to me, class name, it's not. Class. It's not completely semantically correct actually, because you could use. Actually, we do that. I mean, we use it with ints, and an int is not a class, right? It will work. It will work with ints like this. So you could always type class instead. But I mean, an int isn't a class. It's a primitive. So to me, I typically use type name, but I just wanted to tell you that you can use whatever you want, and you will find lots of samples using class instead. All right, so that's templates for functions. Let's look at templates for classes. So let's create a class, and I want to create a class with an array. Yeah. So let's say that they are. We should have some as a private. We should have. What should we say? Let's say int. Things like this. Oh. Okay, actually, yeah, that's okay. I think let's see if I had to modify it to make this show what I want to show. Okay, so let's say now that we have my array, and yeah. I mean, we can't do much. I have no public methods or anything, but I think you can see that we can only use ints, right? We can only use this array. I have no idea in how this array would be better than the real array or the vector. It's not that. That's not my point. But I'm creating something. And as you can see, I'm really tied to using ints. That's my thing. So let's create them. The template. Sorry. And we have type name t, and we do like this. Cool. This really is cool. Now, as you can see, now we can create an array with ints. Great. And we can also create an array of movie, like this, and array 2, like this. And the thing is, okay, sorry, let's see. It's a deleted function. Let's have a look at the movie then. All right, so there is no. Okay. There is no default default constructor. This is one of the things that typically, I mean, this class is not finished. We should have a copy constructor. We should have a lot of things. Right now, let's just create an empty constructor like this. So now it's okay at least. And we could have an array with strings or whatever. My array, I mean. Yeah. So as you can see, this is how the STL is created. I mean, it's really simplified. It's a lot more complicated than this. But the thing is, it's kind of like this. So you could create your own template classes. Now, you might think, but it's a shame we only can say it's 100. It's 100. I mean, and the thing is, we could, of course, maybe pass the size when we created, but as you can see, it's not possible to allocate this from the size variable in some way, because it need to be known at compile time. So the size of this array need to be a compile time. It need to be known at compile time. So how could we make it known? The thing is, when we create, when we use templating, then these, I mean, they are decided, the type name and actually these parameters to the template are decided at compile time. So I mean, at compile time, yeah, it's a movie, so it will be movie then, and it's a string and it will be string here, so that's done at compile time, of course. So we could also have this one as a compile time parameter. So we could say like this. I mean, typically we use n in these kind of scenarios, number, you know. But let's say size if we want. So we could do like this. This is, I mean, this is where this is an example on when templating can get so much more than just, you know, generics. So have a look at this. So now we need to tell the compiler two parameters. So my int 10. So now we're creating an array with 10 ints and maybe 5 movies and maybe 5 strings. We could also, a little later, we could create a movie with 100 instead. And as you can see, there will be two different classes compiled using different values of size. So it's I mean, it's really cool, and when you get used to it, I mean, yeah, to be honest, as I said, it might not be, I mean, every day, but it also depends on the kind of application you're writing. But typically you use templating when trying to, I mean, maybe you are developing some sort of framework or something that is supposed to be used by other developers, or then you tend to use templating more, I'd say. But it's really cool, and it's really effective, and it helps us write less code and just write the code once instead of multiple times.